This is the ladder chain driven clock. You can see the pendulum there swinging. Now that is made out of 1/16 aluminium alloy welding rods. It's all glued together with epoxy resin. That's it. That's a bob, and you can see that if I lift it up, there's a black bush on there which is tight, and that allows me to set the time. Sorry about that. And you can see it's quite a delicate pendulum rod, and the idea of using the aluminium welding rods was for weight, to keep the weight down, get the centre of gravity as low as possible. That is the weight for driving the clock, which goes onto the winding drum there, as you can see, and you can see the cord quite nicely there. It's only about 3/32 diameter, and I've done away with the counterweight, and I've made that 2 holes there. I'll take the key to wind the clock with. If I can just show you that. And remove the clock. Now this key fits all the clocks. Now the difference between a cords and pinion clock and a chain driven clock is that with the chain driven clock all the wheels and pinions go round the same direction. With a clockwork clock with gears engaged in gears, if one gear turns clockwise, the one it's driving goes anti-clockwise. And that caused me problems. I made 3/4 of it before I thought about that, and I thought, well, it's not going to work, but I have made it to work by putting a weight to make the great wheel, which is this one, go clockwise. Everything else goes clockwise, so the hands go clockwise, and it's worked out nicely. I'll see if I can show you some close-ups. All cut from aluminium alloy, soft aluminium alloy you would buy from your local supplier. It's absolutely terrible stuff to work with, but if you keep plenty of methylated spirits or surgical spirits, flood it with a brush, it'll cut just like hard brass for drilling and so on, and the same for your sawing, piercing saw. There again you can see the 2 black discs, the 2 brass discs with the black one in between. That's 1 steel washer and 1 piece of magnetic tape, and again it does the same on this clock. You can just move the hands forward or backward, whatever you like. It doesn't affect the mechanism. Now this is ladder chain. It's called ladder chain. It's the sort of stuff they used to use with Meccano, I believe. And it looks quite a nice clock with all the chains. And I was quite concerned about getting the centre distances first. That's why I drew it in AutoCAD first. Make sure it would actually work. There's your escapement. The same escapement again, but that's made in brass, the pallet. Because I think it would have worn, and it wouldn't have been good to have an aluminium pallet with an aluminium escapement wheel. I think it might have stuck. But with the brass it works fine. The pendulum rod is a bit different, but I thought I'd just make it a bit unique. Rather than using wood, keep it all in aluminium. So that is clock number 3. As you can see, it looks quite nice. Whatever angle you look at it, it's nice. And you can hear by the ticking it's quite even, although I've just again stood it on the top of this table. No settings on it, just put it on the table and it works straight away. Now in this one I've made the hands from 1/16 ply, wood ply that is, because if I made it out of a 16th aluminium alloy it would be so soft. This alloy is very soft. It would have, if it get bent it would just stay bent, it wouldn't spring back. So I've actually made the hands all to the same design as the other clock in 1/16 plywood, and that's clock number 3. This is clock number 4, and it's going to be partly roller chain and partly cams and ratchets. The roller chain will be used for the powertrain, and the cams and ratchets will be used for the timing chain. That's the hands. So that's a roller chain, and I'll show you how they run. So this is the main driving sprocket that the winding drum will be on, and you can see I've actually engine turned, polished it, cut it out, polished it, engine turned it, and then I've coloured it by using an oxyacetylene welding torch to get tempering colours. It's not hardened or tempered, I'll just use that to give me the colour pattern. I'll now show you, this is a depthing tool I've made. You can see there's 2 centre punches, one there and one at the end, and you can adjust this with this little wheel here to tighten them up, bring them closer or wider apart. And I'll attempt to show you this so you can see how smooth it is. Now once I've got that set for the right distance, I can then use that 2 centres at the bottom. What you would normally do is bring that centre to your first mark, like that, and then you would scribe across your plate or whatever it was with the other one. You can then centre pop this mark once it's on its line, drill your 2 holes, and it'll run the same as it does on this depthing tool. So here we are, back to the great wheel as you saw me spinning it round, which goes up there and will drive that second wheel, and that second wheel will then drive the next wheel, which I haven't made yet, having Christmas and New Year holidays in between. The box that that's sitting on is a box that I've made my depthing tool. That's all the bits and pieces, bushes and so on. The depthing tool, it's not my idea, it was one that was in a model engineer, but I've modified it so it's got a micrometer feed for it, as you can see through that. And there, that's a micrometer feed, that brass bit. So that's as far as I've got with this clock. I was going to make it a complete roller chain all the way, like the ladder chain clock, but I've now changed my mind. I'm going to have the powertrain rollers like this, 3 wheels, and then from then on the timing the timing gears are all going to be cams and ratchets. And I can't see any reason why it won't work, but I haven't made it yet. I think it'll be quite nice. So that is the clock number 4.